All right, so let's get started. Just to recap, my name is Marcus Brown. With me also is Bryce Babinek. He's going to be showing us kind of the behind the scenes footage of these parts being made. But what I want to do is just take you through what is possible with one SLS print job on the Formlabs Fuse printer. It's kind of ridiculous. In fact, it's really ridiculous, and you kind of have to see it to believe it. And so what we did is we made this one print job and we took it to these various events called Manufacturing Day. If you missed out, you're going to be able to see everything here. But we've got a lot of components. You can kind of think of this as like a list of parts that have been requisitioned from production. And some of these, we would normally purchase. Some of these we might make on our CNC machines. Some of them, we may have to outsource. But these are coming from a lot of different places, have a lot of different functions. We're going to show you how having an SLS printer really gives you some pretty amazing production capabilities. Let me switch over here to my camera with the parts. And so what we're going to do is just kind of run through real quick and talk about what it looks like and kind of what it does to your company when you have an SLS printer like this available. So the first thing you want to talk about is going to be things like, ROI versus injection molded parts, right? So these types of parts, right? This, for the amount of money this print took, which was, let's see, we've got $170 in unfused material is what we ended up using. And it took 24 hours, basically start to finish, to make every single part you see here. For $170 in material in 2 hours. It's pretty amazing. That puts parts like this in the couple dollar range, which you can't injection mold it, right? You certainly can't, build it efficiently at low volume, right? Efficiently and economically. And so a part like this is an awesome part to start to build an ROI for an SLS printer. And so we built 4 of these, right? These blowers, but that's not enough. Right? An ROI is difficult with just one part. So what we did was we looked at our line and we've got some equipment with some wear parts, right? A lot of times we hear people tell us that they've got a situation where they've got a sub-assembly in this machine that does something, and one gear is what keeps wearing out, but they only sell you the massive assembly or sub-assembly. And so what you end up doing is spending $300 on what amounts to a really cheap but proprietary gear. And so that's a lot of these types of things can be thrown in whenever you need. Make as many as you need, only when you need them. You don't have to worry about inventory. Got a few more things here. This gear, right? This is another wear item. This is just a tube union, nothing fancy or special, but if you've got a situation where you use these a lot, it'd be really easy to just kind of print some up, have them on hand. If you make them thicker or thinner or fit differently, you'd be able to get them exactly how you like it. I've got some of these. These are like these IKEA furniture, captive fasteners, right? If you're using these or you're pulling these off the shelf at a pretty low rate, right, you can probably make them pretty easily. Put them whatever shape or size, adjust and customize the head on these. Here's a whole bunch of panel fasteners. So this is what you would see like in your car to hold the trim and everything in place. Again, you can buy these, but if you have this much production capability in-house, it is possible for you to build them, which opens up some things like being able to customize the heads with, your company logo. It would also give you the ability to customize the engagement depth, the holding force, how serviceable and removable they are, right? Do you want this to be super permanent, or do you want to make it have a little tab here where you can pull off and actually be able to, service it? We printed like 50 or 60 of these consumable wrenches, right? If your part requires some kind of adjustment when it gets to the site, right? You've got either a screwdriver, maybe a wrench, right? Being able to print these in exactly the sizes that your machine needs, even if it's like a custom key or anything like that, would be very easy. This could be longer or shorter. It could be quad. It could be labeled, right? You could even say step 5 if you wanted. Very customizable to kind of improve the customer experience while also being able to build these kind of on demand instead of having to buy them, by the 10,000s and then stocking them and having problems with maintaining that inventory, especially if you have a design change. We see a lot of these types of parts where, like, this is end of arm tooling, right? Perfect example for a durable industrial 3D printer. But we also see a lot of times where people will have like really fancy, let's say powder coating guns, right? They're spraying material. These guns are the best there are. They're really expensive, but any wear item on it requires, a serious, charge and a lot of time to get the part from wherever that vendor is. Being able to customize it, make it longer, make it shorter, right? Anything like that, it gets really easy, and it just kind of enables your team to be able to do a lot more with it. So a lot of stuff in production, even purchasing is going to get on the act, right? With a lot of different types of things that you can do, either quick fixes like this shaft coupler. We've got these bearing housings, right? Maybe it's a specific flange type or something like that. A lot of times you have equipment out in the shop, right? This is a PTO knob. There's only one here. We printed another one. I think that one might have got installed on my wheat truck. But, little things like this, right? They make a big difference, and they are important for your business. Let's start talking about R&D, right? R&D comes to production with some of the craziest ideas I've ever seen. And they say, look, I just want to try it once to see how well it does. Right? If the cost benefit doesn't make sense, fine, but I want to see, right? Usually production's role in that is to say, no, heck no, we're not doing that, right? What if you could just say yes to everything, right? What if you could just say yes to any kind of design, any kind of part? What if you could say yes to iterations every single day? Right? Another iteration, another iteration. Give me 5 of these so I can take it to a trade show, right? Like this one right here. Maybe marketing comes to you and says, hey, can you create some cutaway models of our valve that we can take to the trade show to show off? You say, yeah, no problem. But I'm not going to give you a fully functional, detailed valve from our line. I'll give you something like this that's a demonstrator that shows what it needs to show, right? Cheap enough to give away, very easy to transport. We're not worried if they break it at the build, right? Just really amazing. And what it really kind of ends up doing is it eliminates the restrictions and the settling. You know what I mean by settling? You're like, oh, that's not really what I need, but I guess I'll make do with it. With a printer like this, you could say, this is what I want. This is the soft jaw I want. This is the bracket shape I want. This is the engagement length I want, the shape I want. This is how it fits exactly right. And you can give them whatever it is they need, nearly unlimited, potential for geometry, like this Venturi, right? That would be pretty complicated and possibly pretty expensive to injection mold. Certainly to make variations of it would be difficult. Something like this would be, kind of delicate, thin walls, so it'd be hard to machine. This is absolutely no problem with an SLS printer. So it can really change how your company operates and what kinds of parts you can build and how you enable everyone in your department, everyone in your company on the shop floor in engineering and R&D and marketing. It gives them the ability to really get creative, try things out, and fail quickly and fail precisely, right? With the exact part they need. So this is all good, right? Everybody's like, oh yeah, I used my 3D printer. I made 8,000 of these. And you're like, great. Did that take you, a week of effort, right? Did you spend $5,000 on material? Like what exactly did you do to get there? And so let's go ahead and turn it over to Bryce, and he can kind of take us through a day in the life of operating the Fuse system, the SLS system, show us a little bit about the post-processing and how much time it takes to do. And then we'll wrap up at the end. Bryce, go ahead.
All right, thanks, Marcus. So now we've got a great understanding of all the parts that were requested, and you've seen the actual end result from the printer. So now I'll try to cover everything that happened in between those two things. And we'll start by laying out all of our parts in the virtual world and use software to automatically pack it all up for us. And then we'll go print the parts, and we'll show a behind the scenes look at post-processing for this build. So let's go ahead and get into it. This is Formlabs slicing software where we can set up our parts and our settings for printing. And it's the same software whether it's their SLA resin printers or in this case our Formlabs Fuse. We've already got our fuse selected here and we can see a few of the details for this build, but there's not a lot we can do until we start bringing in parts. And so if this was a case where maybe we were only bringing in one part or one type of part and we needed a lot of them, we would start just by dragging and dropping our STL file in. And for some parts, orientation doesn't really matter. But for other parts, you may want to set up your orientation just so it's consistent visually, and that gives you some control over where the part is the strongest. But to print as many of these as you can, the easiest way to do it is to just slide it into a corner somewhere, and then we can take advantage of our built-in array tool. And this allows us to just scale this thing up in every direction. And by default, we've got this 5mm spacing between parts, but it's a very safe measure, so we can drop this down to as low as 1. And that actually lets us get 1 extra in the X and Y. And then we can do the same thing in the Z direction and build this thing up. And as easy as that, we can have 200 of these things. But in this case, we're not doing just one part. We've got this whole list of parts. So I'll go ahead and drag all of them in at once. So now we've got one of each model imported, but there are a couple of problems. The first one you can see, which is that a lot of these parts are overlapping, and that's why they are highlighted in red. But second, if we were to kick off a print like this, it ends up being really inefficient because the way that SLS works, we fully fill a layer with powder, and then the laser melts the cross section of our parts into that layer, and then the build plate moves down and the process repeats. So one, this type of setup would take much longer because now we've got all these layers to do. But two, everything that's not part ends up being loose powder, and that loose powder gets recycled into future builds, but it has to be mixed with a small amount of new powder to keep using it. And if we run a bunch of builds like this, we just end up with way too much used powder and we might have to dispose of some of it. So that just brings up our costs. But again, we've got a quick and easy solution to this, which is using our Pack All Models tool. And the Pack tool is very convenient because it just pushes all the parts down and reorients them to fit in as small of a volume as possible. And I did mention earlier that there are some cases where you want to keep the same orientation for your model. And we've got another trick for that, which is just XY locking the rotation. So that's already done for this part, and now it can shift around as needed, but it won't rotate. So we're looking a lot better after the pack. We're taking up a lot less volume, our time is going to be lower, and the amount of powder we're using is much less. So that's great, but we still have a lot of parts to add to this. We have one of each, but we need to start increasing the quantities based on what the demand is. And again, we can do that pretty quickly and easily just using our duplicate option. So we can increase to the number needed, and we can just select create, and it'll automatically start populating those. And so we can go through each model and do the same, select the number of duplicates, and then at the end of it, we can pack everything together. I won't bore you with that whole process. I've already got it pulled up and calculated out, and this is what we can see. So we've got every part from that list all packed down into this volume, and it's just this crazy monstrosity of parts altogether. But one of the crazy things about this is all these parts print in less than 24 hours, and that's on the default settings. There is a speed optimized setting that changes how the laser builds the parts cross-section out, and it drops the print down to 18 hours, which is a great option if you're running back-to-back builds and if you want the most parts per week. But default is slightly better for fine features, so I'm going to go ahead and keep it for this build. And now we can send these parts to the printer and we can kick back for another day, and then once it's all printed, we can get to work on post-processing. This is what the actual printing process looks like. And so we roll across a fresh layer of powder here, we outline where our parts are, and then we come back through with the laser and we melt in the rest of the part. And so all of these SLS parts are going to be solid filled, which means they're super strong. And then everything you see here that's not being melted into part is just loose powder that we can recycle back into the system, and we can use it again in the future. So there's very little loss, and it keeps your cost per part down very low. And so now we've got another fresh layer of powder, and it's going to melt the new layer into the previous layer. So we're going to get a lot of strength between our layers here as well. And this continues. You can see on the right-hand side how much time is remaining, and we can even see, based on that little square, where we're at within the build here. All of these pieces print inside of this build chamber, which is removable from the system. And the fact that it's removable is actually a pretty big deal here, because sometimes it can take up to 8 hours or so to cool your parts down. And so if we were running back-to-back prints, we would want to move a new build chamber into the printer and kick that off. And now we can let the old print cool down here in the sift. And in the sift, we will unpack the parts and start to depowder them. And this sift has a hopper for new powder and a hopper for the used powder. And so as we're depowdering these parts, it's actually dropping through down in that little white grate, and it's recapturing that loose powder. And you can spend as much or as little time here with depowdering as you want. So a lot of people will choose to spend a bit less time here and just sort of absorb that powder, any powder loss, into their cost per part. In most cases, the vast amount of the powder is just going to fall right off and be recycled back into the system. So I probably spent a little more time here than I needed. And especially with the cleanup, there's a built-in vacuum that you can use, which is great for us because we use this as sort of a display piece as much as a functional piece of equipment. And then once we're all cleaned up, the next step is to mix our old powder and new powder, so we can use the UI to set that refresh rate. We run about 30% new powder to 70% used powder. And then on the side of the machine, we can even mix all of that together, and it's all automated. It runs for about 10 minutes. And so typically I'll do this while I'm depowdering parts, and that way we're kind of making the best use of our time. Once you have your cartridge and it's all mixed, it's as simple as just putting it on top of the printer and opening the latch, which makes this a really clean way to shuffle our material around. And then this is a kind of a quick glimpse of what these parts look like right out of the sift here. And I probably spent a bit more time than I needed to cleaning these things off, but you can see some of them still have a decent amount of powder on there. And all of that's going to come off in our next step, which is a fully automated blasting cabinet. And this thing is built specifically for SLS parts, which is great because that means it has built-in routines for blasting these and then cleaning them afterwards. And so here we can set how much time we want for our blast. We can set the pressure of our blast depending on the types of parts we're working with, all kinds of custom features. And then the rinse is really convenient. It just gets rid of all the powder afterwards. So here's that blaster working. We've got the tumbler spinning, and we can get every single angle of our parts blasted off and nice and clean. And then this thing is going to separate our media from the actual powder that we use to print. That way it's not deteriorating our blasting media. If there are some weird kind of nooks and crannies that we need to get to, you can re-angle the blaster straight down, and then you can just start to clean these things off by hand. So a lot of these like internal cavities and through holes, some of those will have to come back through and just make sure they're fully cleaned up. But overall, this blasting cabinet saves a huge amount of time. And then the next benefit is that the media doesn't actually stick to the part because there is a deionizer that allows the blasting media to just fall off in the end. And so that allows us to take really good use of this full like cleaning rinse of the blasting cabinet. Once we have our parts out of the blast, they're ready to go. A lot of them are white glove clean because of that rinse. And this is kind of a look at them straight out of the blasting cabinet. Tons and tons of parts, and with maybe 1 to 2 hours of post-processing work. So this machine is incredibly capable, and it's always really satisfying to get these kinds of builds out of it. But that's what we've got for you guys today, and we will stick around for some questions. But otherwise, I appreciate y'all sticking around, and have a good rest of your day. Thanks.